Hey everyone, you know how we're always hearing about these really big AI models that are like revolutionizing
Yeah.
everything? Well, today we're going to do a deep dive into one that's really caught my eye.
Well, cool.
DeepSeek-V3.
Okay.
And what's really got me hooked is how this model tackles a challenge that you and I as developers face every day, right?
Yeah.
Doing more with less.
Right.
So we've got this research paper, and it's straight from arccphi.org.
Okay.
And let me tell you, it's packed with insights about how they built a model that's both powerful and incredibly efficient,
Wow.
especially for tasks that, well, as developers, we care about, like
Yeah.
code and math.
Yeah.
Yeah.
What's really fascinating here is that DeepSeek V3 achieves this through some groundbreaking techniques that
Yeah.
really challenge the status quo in AI development.
Okay, I'm all ears.
Yeah.
Break it down for me.
Right.
What makes this model so different?
Well, one of the first things that jumps out at you is the training cost. DeepSeek V3 was trained for a mere $5.576 million.
Wait, million?
I know, right?
For a cutting-edge language model. I'm used to hearing about training costs in the billions.
Exactly.
Wow.
And that's what makes this so significant.
Okay.
They achieve this by taking a completely different approach to the design and training process.
Okay.
They focused on a co-design of algorithms, frameworks, and even the hardware itself.
Wow.
For instance, DeepSeek V3 was trained on a massive data set of 1 trillion tokens,
Okay.
but it only needed 180,000 H800 GPU hours.
Wow, that's...
To put that into perspective, that's just 3.7 days of training on a cluster of 2048 H800 GPUs.
So they basically found a way to train a super powerful model in less than a week
Yeah,
for a fraction of the usual cost.
pretty much.
That's game-changing,
Yeah,
especially for developers who don't have access to those massive computing resources.
absolutely.
Yeah.
It opens up a whole world of possibilities for smaller teams and independent developers
Right.
who want to leverage the power of AI without breaking the bank.
Yeah.
And one of the keys to this efficiency is their use of FP8 mixed precision training.
FP8.
Yeah.
Okay, I'm familiar with different data types.
Right.
But how does that translate into training a model more efficiently?
It's all about finding a balance between precision and performance.
Okay.
FP8 essentially allows the model to process information faster while using less memory. It's like optimizing your code to use more efficient data structures.
Yeah.
You get the same results,
Yeah.
but with a much smaller footprint.
Ah, so it's like streamlining the calculations without sacrificing the accuracy of the model.
Exactly.
Okay.
And this is especially important when you're dealing with models as massive as DeepSeek V3.
Right.
They also had to overcome another major hurdle,
Okay.
communication bottlenecks.
Communication bottlenecks.
Yeah.
You mean like network latency or something?
Not quite.
Okay.
DeepSeek V3 uses a mixture of experts architecture, which means different parts of the model specialize in different tasks.
Okay.
Now, when these different quote-unquote experts need to share information, it can create delays and slow down the training process.
Ah, I see.
Yeah.
So it's like having a team of specialists who are all brilliant,
Right.
but if they can't communicate effectively,
Yeah.
the project gets bogged down.
Precisely.
Yeah.
But DeepSeek V3 managed to achieve near full computation communication overlap,
Wow.
meaning they found a way for the experts to share information almost instantaneously.
Okay.
This is crucial for maintaining efficiency, especially when you're training on massive data sets.
So it's like they've created a system where the different parts of the model are thinking and communicating in parallel
Right.
with no lag time.
Yeah.
That's pretty impressive.
And it gets even more interesting when you look at how this mixture of experts or MOE architecture works in practice.
All right, let's dive into that.
Okay.
I'm curious to understand how they managed to make an OE model so efficient.
The key lies in specialization.
Okay.
Unlike traditional models where all parameters are active all the time,
Mm-hmm.
in an MOE model, only the experts relevant to a specific task are activated.
Okay.
So for each token being processed, DeepSeek V3 only activates a small fraction of its total parameters.
Okay.
About 37 billion out of a whopping 671 billion.
So it's like having this massive toolkit,
Right.
but instead of carrying around every tool all the time,
Yeah.
you only pick out the ones you need for a particular job.
Exactly.
That's a really smart way to save resources.
And to make sure things run smoothly, they also implemented an innovative load balancing strategy.
Okay.
They used something called an auxiliary loss-free approach and sequence-wise balance loss.
Those sound a bit technical.
Yeah.
Can Can you break those down for me?
Sure, in simple terms, they've created a system that distributes the workload evenly among the experts,
Okay.
so you don't have some experts being overworked while others sit idle.
So it's all about maximizing efficiency and making sure all the parts of the model are contributing equally.
You got it.
Okay. And this clever load balancing strategy is another key factor in DeepSeek V3's impressive performance and cost effectiveness. But there's another innovation that I think you'll find especially intriguing given your interest in code generation.
Okay.
Multi-token prediction, or MTP.
MTP.
Yes.
Okay, you've definitely piqued my curiosity.
Okay.
I'm always on the lookout for anything that can help me code faster.
I hear you.
Tell me more about this MTP magic.
Imagine instead of predicting just the next word in a sequence, your model could predict multiple words or even tokens ahead.
Okay.
That's what MTP allows DeepSeek V3 to do.
Whoa, that's like having a coding assistant that can practically read your mind and finish your code for you.
You're getting the idea.
Yeah.
Not only does this boost performance,
Right.
but it can also be used for something called speculative decoding,
Okay.
which essentially speeds up text generation by making educated guesses about what's coming next.
So it's like a supercharged autocomplete on steroids.
Yeah, you could say that. This sounds like a game changer for code generation.
Absolutely.
Right.
And what's really cool is that DeepSeek-V3 implements MTP in a unique way.
Okay.
It maintains a complete causal chain for prediction at each depth, which leads to more accurate and consistent results.
Okay, I'm officially geeking out over this,
I figured you might.
but we've covered a lot of ground already.
Yeah, we have.
Maybe we can take a pause here and come back in a bit to dig deeper into some of the other technical details and innovations behind DeepSeek V3.
Sounds like a plan.
Okay.
We've only just scratched the surface of what makes this model so special.
Awesome.
Yeah. Welcome back. Before we paused, we were discussing how DeepSeek V3 manages to be so efficient, even with its massive size. One of the key areas they really focused on was memory optimization, especially during inference.
Yeah, you're right. We were just getting into how they handle those huge amounts of data. It's mind-boggling to think about all the information these models have to process.
Exactly, and that's where their innovative use of multi-head latent attention, or MLA, comes into play.
MLA, right. You mentioned it before, but I'm still a little fuzzy on how it actually works.
Yeah.
It sounds like some next-level compression algorithm for the model's memory.
You're on the right track. Think of it like this. When the model is processing text, it needs to remember certain information, kind of like keeping track of context and relationships between words. This information is stored in something called a key value cache.
Okay, I'm with you so far. But what does MLA do to make that more efficient?
Well, traditional attention mechanisms can be quite memory intensive, especially for large models. What MLA does is it compresses the information in that key value cache so the model can store more information without needing as much memory. It's like using a zip file to store a bunch of files. You get the same information, but in a much smaller package.
So it's like giving the model a memory upgrade without actually adding more physical memory. That's a pretty neat trick.
And it has a direct impact on inference speed. By reducing the memory footprint, the model can process information much faster, leading to quicker response times and a smoother user experience.
That makes sense. Now, earlier you mentioned DeepSeek-Mo. Is that just another name for the mixture of experts architecture we talked about?
It is. DeepSeek-Mo refers to the specific way they implemented the MOE concept within DeepSeek V3. And one of the coolest things they did was figure out a way to minimize those communication bottlenecks we discussed earlier.
Ah, yes, those traffic jams between the experts. How do they manage that?
They had a two-pronged approach. First, they limited the number of nodes each token can be sent to during training. Think of it like setting up express lanes for the most important information so it gets to the right expert quickly without getting stuck in traffic.
Okay, so that reduces the overall volume of traffic. But wouldn't you still have some bottlenecks even with express lanes?
Right, and that's where their second innovation comes in. They developed a highly efficient implementation of cross-node all-to-all communication. It involves some pretty technical details about warp specialization and how they designed the network topology of their training cluster.
I'm sensing a but coming here.
You're right. Even with all these optimizations, cross-node communication can still be a bit slow, especially when you're dealing with thousands of GPUs spread across multiple servers. But the DeepSeek team is actually working with hardware manufacturers to find solutions for this. They believe that future hardware designs can address these bottlenecks and unlock even greater levels of efficiency.
That's awesome. It's like they're not just pushing the boundaries of software, but also inspiring innovation in the hardware space.
Exactly. They see the big picture and understand that both software and hardware need to evolve together to fully realize the potential of these massive AI models.
Okay, I'm starting to see why this DeepSeek V3 is causing such a stir. They've really thought of everything.
And we haven't even talked about their ingenious approach to FP8 mixed precision training. Remember how we discussed how FP8 can speed up training and reduce memory usage?
Yeah, it's like finding a cheat code for AI development, more power with less resources.
Exactly. But there's a catch with FP8, something called quantization error.
Quantization error. Sounds ominous. What's that all about?
Basically, when you reduce the precision of numbers, you can lose some information, and that can potentially impact the accuracy of the model. It's like converting a high-resolution image to a lower resolution, you might lose some of the finer details.
So it's a trade-off between speed and accuracy.
To some extent, yes. But the DeepSeek team found a clever way to minimize this quantization error using something called a fine-grained quantization method. Instead of applying the same level of compression to all the numbers, they selectively adjust the precision based on the importance of the data. It's like having a smart compression algorithm that knows which parts of the image are most critical to preserve.
So it's like a custom-tailored compression algorithm that preserves the essential information while still achieving those speed and memory benefits.
You got it. And this fine-grained quantization is another key factor in DeepSeek V3's ability to achieve both high performance and cost effectiveness. It's a testament to their attention to detail and their commitment to squeezing every ounce of efficiency out of the model.
This is all really impressive, but it also sounds incredibly complex. I imagine it takes a lot of expertise to implement these kinds of optimizations.
It definitely does. But what's really encouraging is that the DeepSeek team is very open about their work. They've published their research findings in detail and even offered suggestions to hardware manufacturers on how to design future chips that would be even better suited for FP8 training.
That's great to hear. It sounds like they're not just trying to build the best model, but also trying to advance the field of AI as a whole.
Absolutely. They understand that collaboration and knowledge sharing are crucial for driving innovation. And I think their work on DeepSeek V3 is a great example of how open source development can lead to breakthroughs that benefit the entire AI community.
Okay, we've covered a lot of technical ground here, and I'm sure our listeners are eager to hear how all of this translates into real-world performance, especially for tasks that we developers care about, like coding and math. Ready to dive into that?
Absolutely. Let's see how DeepSeek V3 stacks up against the competition in the areas that matter most to you and me.
All right, let's get down to brass tacks. We've heard all about the clever design and the efficient training, but how does DeepSeek V3 actually perform? Does it live up to the hype when it comes to coding and math tasks?
Well, that's the million-dollar question, isn't it?
Yeah.
And the answer, based on the research paper, is a resounding yes.
Okay.
They put DeepSeek V3 through a whole battery of benchmarks, specifically designed to evaluate its capabilities in those areas. And the results, they're quite impressive.
Okay, I'm on the edge of my seat. Give me the highlights.
Got it.
What kind of benchmarks are we talking about here?
Well, for coding, they used benchmarks like HumanEval,
Right.
which tests the model's ability to generate functional code from natural language descriptions.
Okay, so it's not just about like auto-completing code snippets.
Right.
It's about actually understanding the problem
Yes.
and generating a solution from scratch.
Exactly. And on HumanEval, DeepSeek V3 performed exceptionally well,
Yeah.
achieving a pass rate that's significantly higher than other open source models, and even comparable to some of the top closed source models.
Okay.
They also tested it on MBPP,
Right.
a benchmark that focuses on understanding and solving programming problems. Again, DeepSeek V3 demonstrated a strong grasp of programming concepts
Right.
and consistently produced accurate solutions.
That's really impressive.
Yeah,
So it can actually help developers solve real-world coding problems.
that seems to be the case.
Okay, I'm starting to see the potential here. So it's not just about coding, though, right?
Right.
They also evaluated its mathematical reasoning capabilities.
Yes.
Using benchmarks like GSM-8K,
Uh-huh.
which is a collection of grade school math problems,
Right.
and math, a data set containing more challenging high school and college level problems.
That's right.
Okay, so they really put it through the ringer,
They did.
from basic arithmetic
Yeah.
to more advanced math concepts.
So how do you think it fared?
Well, I'm hoping pretty well,
I would say so.
given everything we've learned about it so far.
On GSM-8K, DeepSeek-V3 achieved near-perfect accuracy,
Wow.
which shows it can handle basic math with ease.
Okay.
But what's really remarkable is its performance on math.
Okay.
It achieved state-of-the-art results,
Wow.
even surpassing some closed-source models that have been specifically designed for mathematical reasoning.
Hold on. I need to make sure I heard that right.
Okay.
An open source model
Yes.
trained on a relatively modest budget
Uh-huh.
is outperforming specialized math models.
It appears so.
That's incredible.
It is pretty remarkable. And it really highlights the potential of their innovative architecture and efficient training methods.
Mm-hmm.
They've managed to create a model that's not only incredibly capable,
Right.
but also accessible to a wider range of developers.
This is starting to feel like a real game changer.
It is.
If more developers have access to this kind of power and efficiency, it could significantly impact the way we build software.
Absolutely.
Imagine the possibilities.
It's definitely exciting to think about.
It is.
And it's not just about raw performance.
Yeah.
It's about the potential to create new tools and applications that were previously unthinkable.
Right.
For example, imagine having AI-powered coding assistants
Yeah.
that can not only help you write code, but also understand complex mathematical concepts and assist you in solving intricate problems.
That'd be the dream come true.
Right?
Yeah. It's like having a super intelligent pair programmer who can keep up with your wildest ideas.
Exactly. And I think that's one of the most exciting aspects of DeepSeek-V3.
Yeah.
It's not just a technological marvel.
Right.
It's a catalyst for innovation and creativity.
It is.
It empowers developers to push the boundaries of what's possible and create truly remarkable things.
Well, I have to say, I'm thoroughly impressed.
Good.
DeepSeek-V3 sounds like it has the potential to revolutionize the way we approach software development.
It really does.
I'm definitely going to be keeping a close eye on this one.
As will I.
Yeah.
And I encourage all our listeners to explore DeepSeek-V3 and see how it can benefit their own work.
Absolutely.
The future of AI is bright.
It is.
And models like this are paving the way for even more amazing advancements in the years to come.
That's a wrap on our deep dive into DeepSeek-V3. We hope you found it insightful and perhaps even a little inspiring.
We did too.
Remember, the world of technology is constantly evolving, so stay curious, keep learning, and who knows what incredible innovations you'll be a part of.
Exactly.
Until next time, happy